Sketch the curve determined by the vector valued function cosine t, sine t, minus cosine, minus sine, plus 1. Now, our strategy is going to be to look for relations among x, y, and z. Those relations are going to give us surfaces, and then the trace of our curve is going to be given by taking the intersection of those surfaces. First relation. Okay, if you take a look at x and y, take their squares, we're going to have x squared plus y squared equals 1. So cosine squared plus sine squared equals 1. Now, in 3 space, x squared plus y squared equals 1 means we can let z be anything. So that's going to give me a cylinder. So I'll put x squared plus y squared equals 1 in the xy plane, and then z anything means I can let z go all the way up, go all the way down. So it's going to trace out a cylinder. Next, take a look at x, y, and z together. So I take x plus y plus z. Okay, you'll notice cosines cancel, sines cancel. I get x plus y plus z is equal to 1. It's going to be a plane, but we get an idea of how it sits. Let's take a look at what happens when we let 2 of the variables be equal to 0. Then the third one will be equal to 1. So that just means we're going to have the points going off by 1 along each axis. To get the plane, we just connect the dots. So that's what our plane looks like when it intersects this octant. Okay, now we just intersect our cylinder with the plane and we get our trace as so. Let's plot a few points just to get an idea of how it looks. So if we let t be equal to 0, what do we get? Okay, well, cosine's 1, sine is 0, and then our z-coordinate's going to wind up being 0 also. So that's going to be out by 1 on the x-axis. Put in pi halves. Cosine 0, sine is 1, z is going to be 0. So that's going to be out by 1 on the y-axis. If I let t be equal to pi, cosine's minus 1, sine is 0, and then z is going to be equal to 2. So that means go back 1 on x and then up 2 in z. So we have this point back behind the yz plane. So that's our trace of our curve.